I couldn't believe it when I learned that engineers actually straightened the Leaning Tower of Pisa. Like, the whole point is that it leans, right? But here's the thing. By 1990, this iconic tower was tilting at 5.5 degrees, and engineers gave it maybe 5 to 10 years before catastrophic collapse. So they had to do something nobody had ever done before: fix a world-famous landmark without destroying what makes it famous. And the way they pulled it off? Pure engineering genius. So basically, the tower started leaning the moment they started building it back in 1173. The foundation was only 3 meters deep, which, okay, not great, and it was sitting on weak clay and sand. The south side had softer clay that compressed more than the north side, so the tower literally started sinking unevenly from day one. By the time they got to the third floor, the tilt was already noticeable, so they just stopped building for 100 years. When they came back, they tried to compensate by making the upper floors slightly curved in the opposite direction, which honestly just made things weirder. But the real problem was that every time they added more weight, more floors, more marble, more bells, the south side sank deeper into that soft clay. By 1990, the top of the tower had moved 4.5 meters from where it should be, and the tilt was accelerating. Now here's where it gets scary. Engineers realized that the tower was approaching its tipping point, literally. The center of gravity was drifting outside the foundation footprint. One small earthquake, one vibration from traffic, and the whole thing could tumble. They closed it to tourists and started a race against time. So over the centuries, people tried all sorts of things to fix the lean, and pretty much all of them backfired. In 1838, they dug a walkway around the base to expose the foundation, which sounds reasonable, right? Except removing that soil made the south side sink even more, and the tilt got worse. In the 1930s, they injected grout into the foundation thinking it would stabilize things, but it just added unpredictable weight and didn't stop the settling. Then in 1993, this one blows my mind, they attached 600 tons of lead weights to the north side as a temporary counterbalance. The idea was to compress the north side soil and pull the tower back, but they placed them wrong at first and the tower lurched suddenly. Tourists scattered, alarms went off, and engineers realized they were inches from disaster. The fundamental problem was that nobody was addressing the root cause: differential settlement in weak soil. You can't just slap band-aids on a foundation problem. By the 1990s, the Italian government assembled an international team of engineers and gave them one mission: reduce the tilt enough to buy another 300 years of stability, but keep enough lean so it's still, the Leaning Tower of Pisa. The target was to roll back about 50 years of tilt, roughly half a degree. So here's the cool part. The solution was called soil extraction, or under-excavation, and it's exactly what it sounds like. Instead of adding weight to the north side, they decided to remove soil from underneath it. If you take away soil, the tower settles into that space, but only where you remove it. So by carefully extracting soil on the north side, they could make that side sink a tiny bit more than the south side, effectively tilting the tower back toward vertical. The beauty of this method is that it's reversible, controllable, and doesn't add any load to the already stressed foundation. They drilled small, angled boreholes under the north side and used a custom auger to pull out soil in increments of just a few liters at a time. I'm talking tiny bites, 90 liters per extraction cycle, spread across multiple drill points. The soil naturally collapsed into the void, and the tower settled by millimeters. Then they'd stop, measure everything with inclinometers and settlement gauges, wait for the tower to stabilize, and repeat. The whole process took from 1999 to 2001, and they removed about 70 cubic meters of soil total. That's roughly the volume of a small swimming pool, extracted teaspoon by teaspoon over 2 years. Now, you can't just start yanking soil out from under a leaning tower without some serious safeguards. First, they installed steel cables anchored into the ground on the north side, acting like giant seatbelts to catch the tower if it moved too fast. Then they wrapped a steel and concrete ring beam around the first level to stiffen the base and distribute loads more evenly. And remember those lead weights from earlier? They kept 600 tons of them in place during the entire under-excavation process as a counterbalance, just in case. Every single step was monitored in real time. Sensors measured tilt, settlement, stress, and even temperature changes in the masonry. If any reading crossed a threshold, they'd stop immediately, reassess, and adjust the plan. The results were incredible. By 2001, the tower had rotated back by 0.5 degrees, about 45 centimeters at the top, and the tilt stabilized at roughly what it was in the early 1800s. Engineers estimate it's now safe for at least another 300 years, maybe longer. But here's the key. They didn't straighten it completely. The tower still leans at about 4 degrees, because that's what makes it iconic. The goal was never perfection. It was stability with character. And that, to me, is what makes this project so brilliant. They took an impossible problem, broke it down into tiny, controllable steps, and turned a disaster into a triumph of patient, precise engineering. So yeah, they saved the leaning Tower of Pisa by making it lean a little less, slowly, carefully, and with a whole lot of math. It's a reminder that sometimes the best solution isn't the flashiest one. It's the one that respects the problem, takes its time, and doesn't try to force perfection. I built this whole terracotta model to show you the process, and honestly, it made me appreciate just how gutsy and brilliant those engineers were. Thanks for watching, and if you want to see more engineering deep dives like this, hit subscribe.